Hey folks, Mr. Dell here. We are looking at a question that has us find where two situations are the same. There's different ways to look at this one, but I'm going to go through, probably build a system of equations, is what we're going to get. So this is coming from CPM's course 3, and this is closure questions, chapter 9. So this is closure 9 161. It says Clay and his friend Lacey are making cookies for the school dance. It said Clay started early and has already made 3 dozen cookies. He can make an additional 2 dozen cookies an hour. So Lacey has not started making cookies yet, but she has a bigger oven and can make 4 dozen cookies an hour. If Lacey starts baking her cookies right away, okay, how long will it take for her to have made as many cookies as Clay? So I want to find out, when do their how many hours will it take for them to be at the same place in making cookies? So this is where I think you could create a table, right? I could have time, so number of hours, be one part of the table, and then Clay's cookies and Lacey's cookies, right? So if I were to do a table and just continue with the time to see when they're going to be equal, we could possibly do that. So if I start with 0, at 0, Clay has already 3 dozen. So these are number of dozens, right? So number of dozens, I'm going to say 3. Lacey would have 0 at 0. In 1 hour, Clay would make 2 dozen more, and Lacey would make 4 dozen. So in 1 hour, Clay would be at 5, and Lacey would be at 4. And then in 2 hours, Clay would be at 7, and Lacey would be at 8. In 3 hours, Clay would be at 9, and Lacey would be at 12. So if we think, where it asks how many cookies will each have. So, or no, if Lacey starts baking, how long will it take to have made as many cookies as Clay? So if I look, she's already, after the second hour, made more cookies than Clay. So somewhere in between the first and second hour is when she makes equal amount of cookies. So it's between the first and second hour. So with our table, we could come up with a nice estimate, say between the first and second hour, but that's not going to give us exactly what we're looking for, is the when and how many. So this is where I may need an equation to help kind of get in there and get the exact answer. So my two equations, I'm going to say x is going to be my hours, right? That's going to be my number of hours is my x, and I'm going to make my y number of dozens, right? Number of dozens of cookies, because it's 2 dozen cookies an hour is what Clay makes. So if I write an equation for Clay, I would say that y, so the number of dozens, is equal to 2 per hour plus the 3 he started with, right? He started with 3 dozen cookies, and he goes 2 dozen per hour. So that's my equation for Clay. 2 dozen per hour, that's the 2x, plus the 3 was the initial dozen that he had. That was the initial value, is equal to the total number of dozens, right? And then Lacey would be y, dozens equal 4 per hour. And she had nothing to start with, so we could just say 4x. So now I've got this system of equations, right? To solve a system of equations, we can use the equal values method, because I want to know at what time is their dozens the same. So this is where I set them equal to each other, right? So 2x plus 3 is equal to 4x. And then I solve for x. So subtract 2x from both sides. I'm getting my x alone here. I get 3 is equal to 2x. Then divide by 2x, or excuse me, divide by 2. X equals, well, 3 divided by 2 is 1.5, or 1.5. So that tells me it right there. So it's at, x, remember, is the number of hours. So we would say at 1.5 hours, Lacey, it says how long will it take? At 1.5 hours, Lacey catches up. We'll just put it that way. Catches up with Clay, and makes, and let's see, well, let's figure that out. So 1.5 hours, I put 1.5 in there. 4 times 1.5 is equal to 6, makes 6 dozens. So she's at 6 dozen cookies, and so is Clay at 1.5 hours. And that's when they're the same. Okay. And that's how many cookies they have, 6 dozens. There we go.